This is section 4.6 on exponential growth and decay. Let me share the screen and show you what's up. Okay, on page 409, we have a basic formula that I'm going to deviate just a little bit from. Okay, so exponential growth and decay, n of t equals n0 e to the rt. Okay, I'm going to be using k. A lot of other books use k. It's a constant. You could use n0 for number. I will use a quite often, a of t, a0, a standing for amount, n for number. P is sometimes used for population. Doesn't really matter what letter you pick. N of t is a population after a particular time. N0 is the initial size. I'm going to be using A0. R is a relative growth rate. I'm going to be using K. A lot of books use that. And T is time. Okay, so let's see, we have 1 through 23 for that. So we'll be doing exponential growth and decay. So problems are on page what? 414. So there's number 1, 3. Oops. 5. Again, I have to raise it up a little bit here. 7, 9. I'm going to change the questions on some of these a little bit also. 11. Anyway, all the problems that we work out, we're going to be working out using that same formula where the exponent is e. Exponent is e. So some of the homework problems, they ask you to use an exponent of 2 or some other base. We're not going to do that. We're always going to use base e. So in my presentation, we're only doing base e. Okay, so there was 11 again. 13. Let's read about 13. 15. And starting with 17, we have decay, in particular radioactive decay. 19, 21, and 23. Okay. Okay, number 1. So I'm going to be using A of t for amount equals A0 e to the kt. Okay, they told me the initial amount was 10, so the initial amount goes there. Okay, and after a time of 1.5, okay, we will plug in 20, double. It asked for double, so that's 20. After 1.5 hours. Divide by 10, gives me 2 equals e to the 1.5k. Take the natural log of both sides. These cancel out. ln 2 is 1.5k. Divide by 1.5. And k is about 0.462098. So I plug that back into here. Again, that's different from the text. The text wants 2 to some exponent. We're always going to do base e. So a of t is 10 e to the 0.462098t. Okay, now they want you to plug in 35. So plug in 35, punch it in the machine. 105,689,838. C, how long will it take to reach 10,000? So that's a new amount. So 10,000 equals 10 e to the kt, divide by 10. 1,000 equals e to the 0.462098t. Take the natural log of both sides. So ln 1,000 is that, divide by 0.462098, and punch it in the machine. 14.95 hours, or close to 15 hours. Okay, number 5. The initial amount was 18,000. The growth constant is 0.08. So 18,000 e to the 0.08t. Okay, part B, the year 2021, t is 8. The experiment begins at the year 2013. So the year 2021, t is 8. So I'm going to be plugging in 8. 18,000 e to the 0.08 times 8. Punch in your calculator. 34,137 foxes. Part C, when will we have 25,000 foxes? So plug in 25,000 equals 18,000 e to the 0.08t, divided by 18,000. 25 over 18 equals e to the 0.08t. Take the ln of both sides to cancel. ln of 25/18 equals 0.08t divided by 0.08. Punch it in your calculator, 4.1 years. Okay, so a rough graph, 0 gives me 18,000. We know how exponential functions look. They all look something like that. Okay, for problem 11, we need to see the graph for that one. Show you what's up with number 11. So number 11, they're doing deer population. Okay, you have 0, 20,000 and 4, 31,000. And then they ask you all these questions about that. So P of 0 is 20,000, P of 4 is 31,000. So 20,000 goes here, 31,000 goes on the left-hand side equals 20,000 e to the k times 4, divided by 20,000. 31 over 20 equals e to the 4k. Take the natural log of both sides. These cancel out. ln of 31 over 20 is 4k divided by 4. Punch it in the machine. ln 31 over 20 divided by 4, 0.109564. So A of t is 20,000 e to the 0.109564t. Then it asks for the year 2018. The experiment begins in 2010, so that means t is 8. So I plug in 8 right over here, punch it out, roughly 48,050. And then D, when will we have 100,000? So 100,000 goes here, equals 20,000 e to the kt, divided by 20,000. 5 equals e to the kt. Take the natural log of both sides. ln 5 is kt, divided by the k, 0.109564. Punch in your calculator, 14.7 years. All right, so starting with 17, we have decay. Half-life of 1,600 years means after 1,600 years, you have half the original amount. Okay, so again, different than the text. The text wants you to use an exponent other than e. We're only going to use e. So we're starting with 22 milligrams. Okay, half of 22 is 11. So 11 goes here, 1,600 goes here. 1,600 years, we reduce to half the amount. Divide by 22. 11 divided by 22 is a half. No big surprise, we're doing half-life. 0.5 is e to the 1,600k. Take the natural log of both sides. These cancel out. ln 0.5 is 1,600k divided by 1,600. Punch it in your calculator. K is negative 0.000433217. And it's a negative number, which it should be for a decay. For a growth situation, the k is positive. For decay, the constant is negative. I plug that in for the k, or r, the book uses r. So A of t is 22 e to the negative 0.000433217t. So now, what's the amount after 4,000? I plug in 4,000 right here. Years. So 22 e to the negative 0.000433317 times 4,000. Punch in your calculator. 3.89 milligrams. C, when will we have 18 milligrams left? So 18 goes here, equals this, divide by 22. 18 over 22 reduces to 9 over 11, equals e to the kt. Take the natural log of both sides. ln of 9/11 is negative 0.000433217t. Divide both sides by negative 0.000433217. Punch in your calculator, 463 years. That's natural log of 9/11 divided by this stuff. Okay, 21. Initial amount of 250 reduces to 200 after 48 hours. Okay, so find the k, divide by 250. 0.8 is e to the 48k. Take the natural log of both sides. Divide by 48. So k is ln 0.8 divided by 48, negative 0.004648882. So A of t is 250 e to negative 0.004648822t. Now it asks for the half-life. So the left-hand side is going to be half of my 250, which is 125. Divide by 250, 0.5 equals e to the negative 0.0046488t. And then an e cancel out. So I have this, divide both sides by negative 0.0046488, punch in your calculator. And so T is about 149 hours, or if you want to write it in terms of days, since it's 24 hours a day, it's a little bit more than 6 days, 6 days and 5 hours. Okay, finally 23, I start with A of T as A0, 0, e to the KT. Half-life of carbon-14 is 5730. So half the initial amount is 0.5 A0. Doesn't matter what the A0 is, half of it is 0.5 A0. And 5730 goes here. Notice I divide both sides by A0, it's all gone. So 0.5 is e to the 5730K. Take the natural log of both sides. And 1.5 is 5730K, divide by 5730, punch it in the machine. K is about negative 0.000121. So A of T is A0, e to the negative 0.000121T. Okay. Now they're asking for 65%. When would we have 65% of the original material? So 0.65 A0 goes here, equals A0 e to the KT, divided by A0. They're all gone. Take the natural log of both sides, ln, ln, ln e cancels out. ln 0.65 is negative 0.000121T, divide by negative 0.000121, punch it in the machine. So T is about 3561 years. Okay. All right, so that was section 4.6.